Page 112, questions 17 to 20.
Okay, now have a look at this question. Okay, I have Elvis and Kurt. Okay, they're throwing balls. And what's happening is the distance between them is 8 meters. Okay, and the traveling time will be 2 seconds. Okay, the mass is 250 grams. So remember 0.25 kilogram. Okay, do the conversion first. So let me now after that. Okay, when doing this kind of question, it's always good to sketch a graph. Okay, so okay, sorry, just let me have a look. I have Elvis and Kurt. Okay, so I have Elvis, I have Kurt. Okay, the distance between these two, okay, will be 8 meters. Okay, and they're throwing a ball. So uh, if you read the question carefully, okay, um, now the ball Kurt catches the ball, okay, at the same height 2 seconds after. Okay, so if I go back, okay, now the ball should travel from here, okay, because it travels in a shape of parabola. Okay, Kurt catches the ball at the same height. Okay, so it will be something like this. The time is 2 seconds. Okay, this, the ball will travel as a parabola, as we learned. Okay, then once we sketch this graph, okay, we are then able to answer the question. It just makes our lives easier. Okay. Question 17. We need to find the maximum height gained by the ball. Okay. Now, question 17. I need to find the maximum height. What do we know about the maximum height? Okay. So, at the maximum, okay, now the vertical velocity. So let's remember when doing this question, we need to. So at maximum height, let's only consider the vertical. Okay. The vertical velocity will be 0. Okay, so yep, and what else is, okay, at the maximum height, the time will be half of the total uh, traveling time, because take 1 meter, well, 1 second travel to the highest point and take another second travel uh, return. Okay, the time will be 1 second because it's at the maximum height. Okay, so what else do we know? We know vertically. Okay, we only consider the vertical. Okay, vertically the acceleration will be minus 9.8 meters per second. Okay, the gravity. Okay, just remember this is a textbook question. For textbook questions, okay, the gravity will be minus 9.8, not 10. Okay, we use 10 in the exam, okay, but for textbook questions, it's minus 9.8. Okay. Then we need to find, okay, sorry, we need to find the height. Basically, we need to find s, the distance. Okay. I have u, t, a, and s. Go to your formula sheet. Okay. Say if I can show you. Okay. Go to the formula sheet. Okay. Now, then I find the equation. Okay. X equals to yep, use this one. Okay, use the third one there. Okay. because I know the final time. So x equals to final time take away half at square. Okay, so let's change. Okay. So x equals to vt take away half at square. Okay, so it will be 0 take away half times minus 1.8 times 1 square. Do the calculations, is 4.9 meters. Okay, question 17 is done. Then let's do question 18. Now, the acceleration of the ball at its maximum height. Okay, so without doing anything, the acceleration will be minus 9.8 meters per second square. Okay, because if you have a look at the diagram, the only force, okay, beside friction forces, the only force acting on the ball will be the gravity. Okay, no matter it's there or at the maximum of there. Okay, so question 18 will be minus 9.8 meter per second square. Okay, since, yep. Now let's do 19. Okay, we need to find the speed which the ball was thrown. Okay, now if you have a look, and when the ball was thrown, we need to find the speed. We need to find the vertical initial speed, okay, and the horizontal initial speed. Okay, so if I do that, okay, let me do. So I need to find both. Okay, so we have to find the vertical and the horizontal. Okay. For vertical, it's clear. So I have acceleration equals minus 9.8. Okay, so well, as what we did before, okay, I know the total time will be say the 2 seconds. After 2 seconds, the displacement will be 0 because vertically speaking, okay, the ball returns to the same height. Okay, we only consider the vertical thing. Okay, and I need to find the initial velocity. Okay, so if I do this, okay, a, t, x, and u, if I do that, okay, so I use the equation oh, sorry. Okay, so x equals to, yep, I use this equation here. Okay, x equals to ut plus half at square. If I do the math, okay, x must be x will be 0. U yep, here it's a little bit hard. Okay, you need to use minus 4.9 t square. Okay, then 4.9 equals to sorry, 0.9 t squared equals to ut. So sorry, sorry, let t will be 2 seconds. Okay, 4.9 times 2 squared. So if you do the math, okay, u will be 4.9 squared divided by 2. Okay. Okay. It will be 9.8 meters per second. Okay. So the idea was the initial horizontal sorry. Okay. Now that's the vertical speed. Okay, initially it moves up this, then we do the horizontal speed. So again, the time will be 2 seconds. Okay. The distance traveled will be 8 meters. Okay. The horizontal speed will be constant. So 8 meters traveled in 2 seconds. Okay, so the speed will be just 8 divided by 2. I have 4 meters per second. Okay, then vertically is 9.8. Sorry, let me do it properly. It's 9.8 meters per second. Then horizontally is 4 meters per second. Okay. The speed, okay, will be Pythagoras series. If you do the math, it will be around 11 meters per second. Okay. Now for question 20, if you have a look at question 20, okay, so which one shows the force acting on the ball? Okay, so after it leaves Elvis' hand, means when it's traveling in the air, on the air. Okay, so when it's traveling on the air, okay, the only force acting on it will be, assume there's no friction force. Okay, so the only force acting on the ball will be the gravitational force. Okay, the gravitational force pulling it down, and horizontally it maintains a constant velocity, so there's no net force. Okay, so the force acting will be, it will be C. Okay, the answer will be C. Okay, so A is wrong, they're all wrong. Okay.